In this previous example, we are using this dollar sign and then followed by a star to represent the entire command line input. So it doesn't matter how many positional argument you have, it's just all concatenated into like a single string. This dollar sign star. But can we actually represent all the positional arguments using an array? So every element in the array corresponding to one positional argument, for example. Yes, we can actually do that. And the way that we can do that, let's suppose we define a new variable that's called argv, argv. How do we actually define that? Again, just like we define an ordinary array in shell script, but this time the stuff that's going to be between the parentheses is going to be the dollar sign star. So we're basically just taking the entire input argument, the command line input arguments as one string, and then we put them between the parentheses. Don't forget, your arguments, your position arguments are actually separated using space. So by putting this dollar sign star inside of a pair of parentheses, you actually is constructing a ordinary array, just like what you are doing on this line. Or on this line, it's basically the same thing, right? And then you can also define another parameter, another variable that's called argc. That's gonna store the total number of command line arguments. You can use the dollar sign hash, the pound sign, or what you can do is to use this just like getting the number of elements in an array. You can do hash and then argv star or argv at, doesn't really matter actually. So that's gonna give you the total number of arguments, the positional arguments, and each of the positional argument stored in an element of the argv array. And suppose if you would like to echo or access the first element, the first command line argument, the command line positional argument, then that's argv0. Of course, you have to sort of enclose it using a curly bracket, right? If you want to access the last one, if you want to access the last command line argument, you can use the argc command variable now. That's gonna be, you can access the value in argc by doing that. But that's the length. That's sort of the length of the array. It's not the index of the last element, because the array is gonna be zero based. It's gonna be zero based. So the last element has the index that's the length of the argument subtract 1. So this one actually has 1, 2, 3, 4 elements in it. But the last one has an index. The last element actually has an index of 3. So that's the length subtract 1. So we have to subtract 1 here. And then we enclose it by using a curly bracket. Now if we run this script now, let's type like 3 command line inputs. So it's gonna print out the first one, the last one, and then the last one, the last command line input. So if we actually simplify the expression by just using $ hash, it should also work. If you want to comment out a certain portion of the code, just put the pound sign at the position where you want to make a comment. The commented out codes are going to be non-effective. It's not going to have any effect on your code. And this change will simplify the code a little bit, but the result is going to be exactly the same. The result is still exactly the same, actually. And these are some examples about how to use the array with shell script. if we go back to look at our codes, the 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 line that we converted, in which we converted a string of command line inputs to an array, is here. That's the line for converting a character string into an array. So this technique for converting character strings to arrays can be generalized. We can basically convert any string of characters into an array. So suppose I define a variable. Let's call it var1, and it's a string. It's just a string of three words separated by space, and we can convert that into a array. Let's call it AVAR3 equals to, again, parentheses. The syntax is basically similar to the syntax on this line, except that here we have to give var1. We have to take the content of var1. Now AVAR3 is actually an array now. So if I want to echo, suppose first element, and then AVAR3, so it's 0. It's supposed to be ABC, and then the last element, and it's supposed to be GHI. Now let's run script 4. So the first element is ABC and the last element is GHI. It's basically a splitting. So this line basically allows you to split a string composed of a number of words, and those words are separated by a space. So this command basically allows you to convert this line, this character string, into an array. And this operation is called tokenize. It breaks up a line or a very long character string into smaller tokens based on some kind of delimiter or word boundaries. Those delimiters are called word boundaries. And the default delimiter or the default word boundary is indicated using space. But suppose you have situations in which the delimiter is not exactly space. For example, if you go back to the shell, you echo the string path, you can sort of see the different absolute paths are actually separated by a colon. So in this case, the delimiter is not really a space, it's a colon. If you want to break up or tokenize this very long string that's stored in path based on the delimiter colon, how are you going to do that? Is it possible to change the delimiter? Yes, it is possible actually. So the bash actually provides a environment variable that's called IFS. The IFS is actually represents internal field separator. It's an environment variable that defines what's going to be the default delimiter that can be used for breaking up or tokenizing a character string. So if you echo $sign IFS enclosed in a double quotation sign or this internal field separator, you're going to see there's like two empty lines. The reason that you don't see anything that's being printed here is because the IFS by default is defined as the empty space, the tab, and the new line. So if you want to look at the content explicitly, you can pipe it through cat-A. So here you can sort of see there's an empty space here. This hat I actually represents tab, and then this $sign is sort of the end of the line. It's a new line. So the default content of the environment variable internal field separator or IFS has three symbols stored in it: the space, the tab, and a new line. This cat -a option, we didn't talk about this -a option when we talked about the cat. So if you want to look at the -a option, you can do man cat and then just search -a, and it's a show all. It allows you to see all the hidden characters. So if you would like to use a different delimiter, if you would like to use a different word boundary, you can set the IFS to a different value, for example. So now let's go back. Let's go back to our script 4 and see if we can actually change the value of IFS. So let's try to sort of split up or tokenizing our environment variable path into an array. And I'm going to change IFS to the colon. And then I'm going to define a variable, an array variable that's called a path. And it's going to equal to, again, parentheses. But now I'm going to give it my environment variable path. Now let's look at what's actually the length of a path. Let's just echo a path star. Then it's going to give me the total number of paths that's sort of included in the path environment variable. And then let's echo, for example, the first one. The first path, and see what's going to happen. Now let's execute the script 4. Give it some arbitrary input variable. Here's the printout of the length of a path. It has 19 different paths that's concatenated into the path environment variable. And then this is actually the first element in the a path. So if we want to echo path, the first element, the first path inside of the path environment variable is indeed a user local sbin. So this is actually a very general way for tokenizing a particular character string based on any kind of delimiter that you specify, either by using the default, which is the space, the tab, or the new line, or some character that you specify by changing the IFS environment variable. But why is it useful to convert a character string into an array? Let's look at one particular scenario in which we want to count the number of words in a text file. Suppose let's look at in my current directory I have an arbitrary text file that's news.txt. It's something that I just copied from the internet, shows today's news. If I do a cat news.txt, it's going to show me some arbitrary text. Donald Trump remains at center stage in the Republican presidential contest Sunday. So I want to count how many words I have in this particular text file. And so the words are of course separated by space. As you can see, it's sort of the space, the empty space is of course a delimiter, right? It separates the words. It's one of those word boundaries. But you can also note, you can also sort of see that the comma is also one of the delimiter. In this particular case, comma clarifying, so there's no space between Sunday, this word, and clarifying except this comma separator. There's no space in front of or behind the comma. And then there's another word, there's another separator that's a delimiter, that's the period sign, that's the dot. Again, there's no space before or after the dot either. So this is a word, but this is another word. Jeb Bush is a name actually, but gov.jeb, it's actually two words, but they are separated by just a single dot. It's not a space. And of course, you also have the new line. So here you actually can see there's a new line. That's a carriage return. So it has switched to a different paragraph here. So this is the end of the first paragraph, and this is the beginning of the second paragraph. So there's a so at least you have 4 different types of delimiters: space, the comma, the period, the dot, and a new line or carriage return. So if you want to count the number of words, of course you can try the WC command. The WC command allows you to count the number of words, right? So WC print new line word and byte counts for each file. You can try WC. So it has an option. That's -W, I think. So words print the word counts. So if you try to WCW news.txt, and then it's gonna tell you you have 52 words. But in fact, this text file actually has 54 words. The reason that the WCW command is giving 52 words is because this comma and this period, it's not used as delimiter in WCW. So gov.jib is counted as one word, and Sunday comma clarifying is counted as one word. So the number of words counted by WCW -W is actually 2 words less, 2 words fewer. So if you want to write your own script for doing that, you can try this. Let me. So let's write a new script. Let's call it script 5. Again, the shebang line. Now, how do I get the completed text into a variable? Suppose. How do I do that? So I can use the backtick. I'm gonna cat the first command line input. It's the positional variable, and I'm using the backtick, a pair of backtick, to expand this command. So VR1 will hold the output of cat. So $1 is sort of the positional variable. It's sort of the positional argument. It's a representation of the positional. It's actually the first command line input. I'm gonna use the first command line input as the text file that I will compute the word count for. Now let's try to change IFS. That's the internal field separator. Let's try to change it to a value. I'm still going to use the default value that's already stored in IFS. So I'm going to use a double quotation, and then the interpreter, the bash shell is going to interpret this as a variable. That's an environment variable, and it's going to expand it. It's expanded using the content that's currently installed in IFS. That's sort of the default delimiters. And on a typical shell, it's the default delimiter is the tab, the space, and the new line. So I'm gonna keep using those delimiters, but I'm gonna add 2 more. I'm gonna add 2 more delimiters. One is the comma, and then there's another one that's the dot, the period sign. And now let's convert var1 into an array variable. Let's call it avar1. Now equals to var1. Now avar1 is an array variable, and it has been tokenized using delimiters that's specified in this new IFS. So this new IFS equals to the default IFS, which is the tab, the space, and the new line, together with comma and then period. Now all I have to do is to echo the total number of elements in this array. So that will allow me to echo the number of elements. So total word count. And then let's add the execution permission. Now let's try to execute it. script 5.sh. I need to give it one command line input. That's news.txt. Total word count 54, and it's actually giving me the correct word count. It has 54 words. I myself have counted it manually. So this is one example of how you can actually uh, why tokenizing a particular string into an array might be useful. Of course, once we have discussed the loop, once we have discussed how to actually carry out loop inside the shell script, you'll find new applications of this kind of utility, the tokenizing utility. One slight modification of the script is to make the delimiter, make the additional delimiters that you added to the defaulted IFS environment variable to be also a command line input. So if you want to do that, you can just change this particular line. Instead of appending comma and the period behind the default IFS environment variable, you can put a positional argument in there. That's your second positional argument actually. The first one is for the text file. The text file you're going to use as the input, and then the second one is sort of the delimiter, or the set of delimiters you want to use. So we can try that. So now I'm calling script 5.sh with two command line arguments. One is the text file itself, news.txt, and then the delimiter. The delimiter I want to add to the default IFS. That's a comma and period, and then it's gonna give you the exactly same amount, same word count. So you can remove, for example, if you remove one of them, if you remove the period from the second argument, then you're gonna get one word less because as you can see from the, if you remove dot, then gov.jeb becomes a one word. So you have one. It should be two words, but you get one word from this because the dot is not treated as a delimiter, so it's not splitting it into like two words. So, and if you just do dot but without the comma, then it's still gonna give you like 53 words because this Sunday comma clarify is treated as one word now because comma is not a delimiter. So Sunday comma clarify is treated as one word instead of two. So you get one word less. And but if you add both of them, it's gonna give you 54. Now let's look at how we can read input from the standard input from the keyboard maybe. And let's write a new script. Let's call it script 6.sh. Again, the shebang line. Now I'm gonna print out some prompt first on the screen. I'm gonna give echo a -n option. If you haven't used -n option before, -n just tells echo not to print a carriage return, so it's not gonna move the cursor to the next line, to the new line. So I'm gonna just echo print enter your name, then comma, and then I'm gonna use the read command. The read command allows you to read from the keyboard. Let's just call the name, and then I'm gonna echo hello, and then followed by the name. So here, when you read something from the keyboard, you don't really have to append the variable name with the $sign. But when you try to retrieve the value, when you try to use the value that's stored in the in the variable name, you have to prefix it with the $sign, which means that you are using it, you are retrieving the value in it. That's for reading just the one input. This one input. Now let's try to first and the last name. So I'm gonna ask the user to enter two inputs, the first and the last name. So I'm gonna read first. So first is gonna be a variable, a user variable that's gonna be used for storing the first name. And then I'm gonna read a second variable that's last, and last is gonna be used for storing the last name that user enters. And I can then hello, and then first, again, $sign first, and last. Make it executable, and then just run it. 6.sh. Enter my name, so I'm gonna give it my name, and then it's gonna say hello PoChain, but this PoChain is treated as one word, so the parameter, the variable name is gonna store the whole text string po space chain. Now it's asking me to enter the first and the last name, so I'm gonna enter po first and then space and then chain. Now first is gonna be po, and then the variable first is gonna store po, and the variable last is gonna store chain. So this is sort of how you can actually read one or two parameters or two inputs from the command line. If you would like to read command line inputs, if you would like to read the user inputs on the keyboard to an array, you can do you can use read-a. Read-a. Suppose I'm gonna echo some prompt. Enter your favorite food, for example, and then you expect the user to enter a sequence of his favorite foods. So, and then you can put it into an array using the -a option. So everything that's going to be entered by the user is going to go into the array that's food. And if you want to sort of display the content, for example, the first element in the food array, if we would like to print out the first three, for example, the first three foods in the food array, then you can do this. Let's comment out the lines that's in the front, so they won't have any effect. Now let's try to execute the script 6. Now it's asking me to enter my favorite food. So let's see. Lobster, steak, ice cream. I'm just entering 3, and then it's gonna print out lobster, steak, ice cream. So the array food is gonna store everything that you enter on the command line, and they are gonna be separated by space. So suppose you enter them with a different delimiter. For example, you are using a comma, and then that's not exactly what you wanted because you have a comma that's behind it. So the default behavior is to split according to space. Now suppose instead of reading from the keyboard, we would like to read from a file, a text file, but one line at a time. Last time when we tried to read a file, we were using a cat. We were using the backtick with a cat, and then, for example, news.txt. We were just using the output of the cat command and then assign it back to a variable. So this gives you the entire content of a text file inside of a variable. So this kind of technique works, but it may not give you a fine control, very fine-grained control, because the entire text file is just suggesting like one variable. It doesn't give you any control during the reading process, and it doesn't remove any of the new line character returns after each of the line. So another way for you to read from a text file is just by using the read command. So I'm gonna use read line, but instead of from the input, I'm gonna use a redirection. I'm gonna change the input source from the standard input to a particular file. Let's say news.txt. I'm gonna comment out the lines at the beginning, and then we can just echo line, and then followed by the variable line. And if we execute it, 6, that's gonna print out the first line in that particular text file, news.txt. So if we do cat news.txt, it has just 2 lines. It has just 2 lines. That's the first line. That's ended with a character return actually. And then that's the second line, which is ended with another character return. So suppose you have multiple lines in a text file. Is that going to work if you just do multiple reads? Is that going to work? So if you do another read line, news.txt, and then do another echo line, is that going to read the second line? The answer is no, it's not going to read the second line. It's going to read the first line again. So what might be the appropriate way for you to keep reading, a file, until the one line at a time, until it reaches the end of the file? So in this case, we have to introduce the loop structure for shell scripting. So a loop basically allows you to repeat doing something continuously until a certain condition is satisfied. So in our case, we're gonna keep reading by using the while keyword. So the while keyword is one way for implementing a loop structure in a script. So we're gonna keep reading while read a line, and then do. If you on the second line, if you use the tab in a Emacs editor, it's gonna automatically indent it for you. So while read line. So read line is gonna return, this read command is gonna return a true if it succeeds in reading a particular line from if it succeeds in reading some content into this variable line. And while is going to look at the condition that's behind it. And if the condition is true, then it's going to execute the line that's sort of in here, the line that's after the do command, the do keyword. And if it is false, for example, if you have reached the end of the file, and this read command gives you a false, and then while is going to terminate the loop. And in that case, it's going to move to done. So this is one way of constructing a loop. It just consists of 3 lines, while, and then followed by a condition. In this case, the condition is produced by the read command. And the read command tells the y keyword if it has succeeded in reading a line. And then do what? Do this. If the condition is true, then do this echo. It's going to print out the content of the line. And then the whole loop structure is terminated with done. But now you are not sort of trying to read from a standard input, so we still use the redirection. But now let's give it some text file. So this way it's gonna print out the 2 lines. So that's the first line, and then that's the second line. And that gives you the desired effect. It will give you, it's different. The printout is different from the previous implementation. That's the first line, and then that's the first line again. But now it's different. The first line and then the second line. So this is a basic way for using a while loop for you to read text files one line at a time. Of course, if you want to replace this hardwired text file name using a command line input, you can do that. In this case, I'm using the first command line input, the position argument, the first position argument as the input, as the text file that I want to read. So if that's the case, I can just script 6.sh and then followed by the news.txt. News.txt. and then it's gonna print those different line numbers, different lines in the text file. If you would like to add the line number during the printout, suppose you want to echo line followed by some number, line number, and then the content of the line, then you can define another variable. Let's call it IVR equals to 1. Let's initialize IVR to be an integer 1, and then we can increase the IVR. We can IVR equals to, give it an expression expr, and then takes the existing value in IVR and then plus 1, and then assign it back to IVR. And in this way we can echo line and then the value of IVR and then followed by a colon and then the line content. This way it's going to automatically increase IVR for every iteration. So IVR allows you to actually count how many loops, how many iterations you have carried out for the entire text file. So let's give it a try. News.txt, and then it's going to print line 1, and then that's the content of the first line, and then line 2, that's the content of the second line. And then of course I can give it some other text file. Suppose I give it a script 5.sh. I can give it another text file, and then it's going to print line 1, it's this, line 2, it's empty, and then line 3, some other commands. It's that's the script that we have used for counting the total number of words in a text file. So if you are interested in displaying the line number during reading the text file, you can do that easily by introducing a second variable, and then you can just increase the second variable, this loop index, the loop counter, or by using an expression, just increase it every time by 1. So for the first loop, for the first iteration of the loop, it's going to be IVR is going to have a value of 1, then it's going to echo line, and then the value is 1, and then the content of the first line, and then IVR is going to change because you're assigning this particular expression back to IVR, and this expression is computed by using the existing value in IVR and then plus 1. So you're adding 1 to the existing value of IVR, and then the result of this particular expression is assigned back to IVR. So for the first iteration, IVR has a value of 1. 1 plus 1 is 2, right? And it's a backtick to evaluate this expression using the expr command. So the result of this backtick is going to be 2, and that value 2 is assigned back to IVR. So for the second iteration, you start from this while line, and then it's going to read a second line, and then it's going to echo line. Now the current value in IVR becomes 2, and then the content of the line, and then IVR is going to increase again by 1 to 3, and then it comes back to the while line. But this time, if you are giving it a 2-line text like news.txt, this time read line is going to fail. It's going to return a false. So this time it's not going to print because the file has finished. It has finished reading the entire file. So it's going to not. It won't execute these 2 lines anymore. But instead it's going to come down to done. And if you would like to echo the IVR at this stage, you can do IVR and then IVR. So IVR by the end of after you have finished reading the file, IVR should have a value of 2. No, IVR should have a value of 3 actually. IVR should have a value of 3 because it started with 1. Started with 1, reading the first line and then increase it to 2. And then it's going to read the second line and increase it to 3. And then when it starts to read the third line, it fails and jumps out. So IVR is going to have a value of 3. So let's see if that's true. Still give it a news.txt. So IVR is going to have a value of 3. The total number of iterations it has carried out is actually 2. So if you would like to tokenize every line into an array of words based on some delimiters, for example, comma and dot, the period sign, you can also do that inside this while loop. So basically what you have to do is to tokenize every line. Basically you have to tokenize every line based on some specified delimiter. That's in IFS, for example, in the environment variable IFS. So the naive way of doing that is probably just to change the IFS here outside of the loop. Suppose you change IFS equals to, for example, IFS, the default IFS appended with a comma and a period, a dot, and then you can just define a new variable. You can just define a new variable. For example, I'm gonna insert my added line here. I'm gonna suppose AVAR equals to the parentheses and then line. But what I can tell you is that this won't work because the IFS, this environment variable, also affects the behavior of read. So by default, if you are using the default IFS, read is gonna read a line until it sees a character return, a new line symbol. But if you change the default IFS to append with to include also comma and the period sign, then the read command is not gonna read until the carriage return. It's not gonna read just one line at a time. It could just read one word or just one sentence. For example, a sentence that's ended with a period, and then it's gonna just read that sentence as a line instead of just instead of sort of reading until the first character return. So it's gonna change the behavior of the read. So what might be a solution, right? What might be a good solution for you to sort of avoid this kind of problem? So one way of doing that is to move this line to the inside of the loop. So when you do the read, it's still gonna use the default IFS. But when you do the tokenizing, splitting the line into an array, before you tokenize, before you actually split the line into multiple words, you change the default IFS. But if you want to go back to the old IFS, the default IFS, you have to sort of, how do you actually go back to the default IFS? You cannot do that because this is not going to work. It's not going to work because you have changed the IFS to the default IFS and also the comma and the dot. So at this point, the IFS already has a value that's the default IFS, which composed of the space, the tab, the new line, and also including the comma and the period. So at this line, if you assign the IFS back to IFS, you are not really changing anything because the default IFS has already been destroyed. You're assigning the changed IFS back to the IFS itself. So what you have to do is to, before you actually change the value of IFS, you have to assign it back to a different variable. So OIFS, that's the old IFS. So I'm going to use a different variable, OIFS, to store the default IFS before I change the default IFS to the new value. And then I'm going to split the line based on the new IFS. And then I'm going to change the IFS back to the default one. And now the default IFS is now in the old IFS now. So all I have to do is to assign OIFS back to IFS. And then when it starts to read the next line, it's not going to change the behavior of the read command. So this way it's going to give you the correct behavior. Suppose you still would like to count the number of words, the total number of words in a particular file. So what you can do is to define a new variable. Let's call big N. Big N equals to 0. It's gonna accumulate through the iterations, and then we're gonna introduce inside of the loop. We're gonna introduce a small n. Small n is just the total number of words for each line. So if I want to get the number of words for each line, all I have to do is to count the number of elements in AVAR, and we know how to do that. So small n is the number of words in a line, and then big N has to equal to, again I'm gonna use the backtick expr. I'm gonna use big N and then plus small n, and then let me comment out of this line. Instead I'm gonna echo number of words, total number of words, and then followed by big N. So big N started with just a 0, but for the first iteration of the loop, big N is going to change its value from the old one, that's the 0, to 0 plus some number. This small n, the number in small n, and the number in small n is actually the number of words for the first line in the text file. And then for the second iteration, big N is going to have a new value. This new value is actually the number of words in the first line. And then for the second iteration, it's going to be the number of words in the first line plus, again, small n. But this time, small n is going to have the number of words in the second line. So this way, when you do the iterations, it's going to, the big N is going to increase. And every time the amount of increase is the total number of words for the current line. And let's give it a try. And then the total number of words is still 54, and it's actually giving you the correct number of words actually. So it's a different way of doing things. It takes longer lines, but you can sort of see that it's more flexible. It allows you to do a lot more than just counting the number of words. For example, if you would like to extract the last word for every line, and then you would like to make a directory from that last word or something, or if you would like to do some generate an empty file based on that last word or something, anything that you want to do can be implemented inside of this while loop. Of course, if you want to specify your own delimiter, for example, if you don't want to use a comma or dot, you can give it a second positional argument. So the first positional argument has been used to specify the text input file, and you can use the second positional argument to specify the delimiters that you want to use, for example. So I'm going to do dot, and it's still giving 54. So what we have learned so far from this particular script is, first of all, we studied how to read from the command line input, from the standard input, from the keyboard by using the read command. How to read one variable, how to read multiple variables, right? And then how to read stuff into an array, right? And then we looked at how to use a while loop together with the read command to read from an input file instead of from the standard input. And then we looked at how to tokenize every line that you read into the line parameter, the line variable. How do you tokenize it? The idea for tokenizing a line is basically similar as we did before by changing the delimiter inside of the IFS. But this time we have to remember to reset IFS back to the default values before the next iteration, because the read command is going to use the IFS to determine where is actually the end of the line. And then we also looked at how to actually do some calculations by accumulating or by summing or by adding new numbers to an old number and then sort of accumulate that number and tells you uh, how to accumulate a number. Now let's look at the while loop in some more detail. So let's write a new script. Let's call it script 7.sh. So let's try to introduce two variables first. Loop count. It's gonna be an integer that counts how many loops we have carried out in the while loop. So we're gonna initialize it to a number 0. And for this particular example, we're gonna compute the summation of the first 5 even numbers. The first 5 even numbers. That's 2, 4, 2, 4, 6, 8, 10. We're going to do a summation of these 5 numbers. So we're going to need a variable to store the summation. So let's call it esum, even number sum, equals to 0. We're initializing it to 0. And then we're going to do the while loop. The while loop, the condition that you specify for the while loop can be enclosed in a pair of square brackets. And the condition that we're going to use is called loop count. We're going to compare loop count with a pre-specified number, that's 5. We want the loop count to be smaller than 5. So the way for specifying smaller than is sort of -lt. So -lt means less than. And you can imagine what's going to be the greater than. Greater than is going to be -gt. And you also have a less than or equal to, which is represented by -le. So -le is going to be smaller than or less than or equal to. And you also have ge, that's greater than or equal to. And you also have eq, that's equal to. So if you want to compare these two numbers, see if they are exactly equal to each other, then you have a -eq, equal to. And then you also have -ne, that's not equal to. So the comparison operators that they can use in a shell is a less than, that's -lt, less than or equal to, -le, -gt, larger than, -ge, larger than or equal to, and then you have eq, that's equal to, and then -ne, that's not equal to. So you have like a 1, 2, 3, 4, 5, 6 operators that you can use for comparing two numbers. So we're going to use lt, less than. So we're going to do the content of the loop when this condition is true, when the loop count is smaller than 5. And then you can just write comma do. If you don't like this particular syntax, or you can write it like that, and then do. And then that's the content of the loop. So suppose I want to increase the loop count first. I'm going to increase my loop count. So how do I use a backtick and then expr equals to the existing loop count value plus 1. So this is how I'm going to increase the loop count by 1 for every loop. And then I'm going to define another number that's increment, the number that I want to add to esum. So the increment is going to be another expression. I'm going to do expr, and I'm going to use the loop count multiply with 2 because I just want to add even numbers together. So loop count is a number that increases from 0 to like 4. And then loop count at this line, I increase the loop count by 1. So the loop, for every iteration, the loop count is going to range from 1 to 5. So 1 to 5 times 2, then it's going to be 2, 4, 6, 10. Exactly the sequence of numbers that we are going to need. But for this particular line, you have to be careful about the multiplication, because the star in a shell script, the star actually has different meaning, has a different meaning from multiplication, because star is also used as a wildcard, so it's a special character. So if you want to use the star as a multiplication, you have to use the escape a backslash, and then that's gonna give you a multiplication. And then we're gonna add the increment to esum. Esum equals to expr, the existing value in esum, plus the increment. And then backtick. That's my esum. So once I'm done writing this loop, I finish the entire loop structure with done. And then if I want to display the sum, I can do an echo, and then esum. If I make it executable, it should print out. If I execute it, it should print out the number 30, and that's exactly the summation of the first 5 even numbers. And you can sort of see the entire structure of a while loop. You put a condition inside of the square brackets, but you have to make sure that there's a space, there's one empty space after the left square bracket, and one empty space at the beginning of the in front of the right square bracket. Those two empty spaces are mandatory. You have to sort of keep them there, otherwise you're gonna get some syntax error. And for the expr, you have to make sure that the binary operators has to have spaces in front and after. Otherwise, the expr is not going to work correctly. And so that's a while loop. How you can use a while loop to do some simple calculations. In addition to the while loop, you also have a loop that's called until loop. It's another loop structure that allows you to iterate a certain command. So let's try to sort of do an until loop. We are gonna add an until loop to this script also. This time we're still gonna compute a summation of 5 even numbers, and then we're gonna compare our results. So again, let me specify loop count. Let me change the loop count to 0 again, and then esum also change it to 0. And then let's write the until loop. So the until loop looks actually quite similar to the while loop, except that the logic is sort of opposite. You still use a square bracket to specify the condition, but now the condition that you want to use is loop count dash ge 5. So you want to execute this particular loop body, a sequence of commands you're gonna execute it until loop count is larger than or equal to 5. So again, let's do. First, we're gonna let me just copy over a sequence of commands, then done. Oh, in fact, I'm gonna copy everything. I'm still gonna increment my loop count, and then I'm gonna compute a increment that's basically an even number, loop count multiplied by 2, and then I'm gonna add that increment to esum, and then assign it back to esum, and in the end I'm gonna print out the esum. Let's just compare if these two results are identical, because they are essentially doing the same calculation, except that the two loops, the loop conditions are different. This one is gonna keep iterate while the loop count is smaller than 5, and this one is gonna iterate while the loop until the loop count is larger than or equal to 5. But in principle, they are actually carrying out exactly the same calculations, and they are indeed giving exactly the same results. So you have both a while loop and also an until loop in the shell script. So you can use either one of them depending upon which one is actually convenient, or which one actually is more natural in terms of the logic that you are trying to implement.